I'm Salvin from 8894R, and I was just going to do a little robot explanation for this robot because I've been running it since December. There's a lot of cool stuff on it. It's kind of hidden away I wanted to talk about, even though it's not really that special as a robot, I'd say. So to start with the drivetrain, we got 6 motors and 450 RPM, 3.25-inch wheels, like standard drivetrain. Pretty much everyone's running it now. I guess I got like dyed wheels. I got the 2-inch wheel. And I got structural screw joints, so like the standoff is tightened against like a nylock in there. Same kind of thing here, like nylock on the other nylock in there. Tightened against each other, so it keeps it really strong. Yeah, we got these pretty standard U-channel funnels on the back and the front. The back's for like the aligner to help it out. The front's for funneling the blocks. The robot's like pretty good at funneling for being a one wide intake, I guess. I have some videos of that, but I'll show them after I talk a bit more about the funneling. So yeah, we got like all rubber bands on the bottom stage of the intake. As you can see, they're all like kind of zip tied together to prevent them from splitting apart and blocks coming through. So I kind of copied that from Nameless. It worked well, so yeah, that's kind of why I did it. And the rubber bands, in my opinion, are better than mesh because they don't wear out as easily and get ruined by like mesh does. And especially for longer stages like the top stage, if you have like the bottom pulling it tight, like when you're storing, then the top's gonna be too tight, and like vice versa. So yeah, with the zip ties and rubber bands, they're all independent kind of, so it doesn't have that same issue and you can tune it more easily. So yeah, and then to extend the funnels, we also have these metal plates that are braced with standoff so they don't bend too much. We actually had issues with entanglement in one of our Elam's matches, but we were focusing on skills, so it wasn't that big of a deal. And it was really good for skills because this thing's able to intake 3x2 from the park zone from any side, and it's really easy. It's really good at it. I'll put some videos. And then yeah, what helped with that is also this pre-roller spacing. I got it from 1412E. And yeah, we got different hardness flex fields on either side and different banding, which can help like bias one side. And then we got like this kind of unique band roller thing in the middle that really helps to get like intake from the front of the park zone. And yeah, we don't got like one in the middle to bias the middle of the park zone because then the mash loading would get messed up. So yeah, we have this set up. Works really well. And then yeah, we got double chain set up here for the first 3 stages, where yeah, we have 1 to 3, 2 to 3, 1 to 2, which means that if any one of these chains snaps, it'll still work, because we had issues with the inner chain snapping and the outer chain snapping sometimes, so it just prevents issues from that. We also have these half-cut 3-wides all around the robot, like pretty much everything's built out of them. That way we can like save some weight at the top, get some better center of gravity without having our robot be too weak like it would be with regular L channels. So yeah, we have these standoffs everywhere, triangle bracing everything. And then we also have this L channel in particular is like on the inside here, so the high strength axle is like stronger, so we have that hit stuff first so that we don't have issues with this thing bending at all. And yeah, I guess it's about it for the very, actually no, we also have this intake razor piston here so that we can get 6 in the low middle goal pretty easily. I was able to hit 115 driver on the practice fields at Provincials, but I kept choking on every single official driver run. I guess, yeah, I also got this match loader here, spent a long time designing this one. So I had a few different designs where I had like all these like ridges on it or like L channels to align it. But in the end, just a simple long sheet with multiple pillow blocks, Deller in so it doesn't bend because it's super long, and the pillow blocks help with that too. And this worked out the best for me. Like, yeah, just make sure you have a nice hard stop there for this, nice banding. Have a slit in the middle in case it's the diamond shape. Make sure that the height is like well tuned and really consistent. What helped is having these hard stops here, and then having the piston perfectly tuned so the end of the stroke length is exactly where the height that you want it, and these hard stops. Yeah, we have the standoff to kind of extend the piston and be able to mount it directly on the structure here without interfering with this. And then yeah, we have these spacers here to reduce piston bending. This piston's completely straight. You can have to ram into the wall every single time in skills, and it matches. We have these wall riders because our provincial fields are metal, and they're like much bigger than what you would need for a plastic field because they extend out from the drive. But like there's all these ridges in the metal field that we kept getting stuck on, so we made sure that we had nice big ones. And then we also have like these nice kind of sleds that like will protect that high strength axle and make sure our barrier cross is nice and smooth. And then this section's like kind of hand cut and messed up, but it's just to make sure that these idler gears don't get touched, and this thing can actually like touch the parking barrier when we're crossing it. And then yeah, this is just to kind of go over the ends more smoothly, I guess. I don't know what else to say about that. We've got these triangle braces. Haven't seen these much except for on 36830A, I believe, is Herb Derb's team. These are really useful, especially with the yellow channel structure, to prevent like when the match load goes up, like the whole structure would kind of twist a little bit. It was like really jank. So yeah, these things really keep it stable. Kind of added those really recently. And then I have this simple triangle brace to, of course, brace the whole intake and everything super well. And yeah, you'll notice we don't actually weight save much at the bottom. We use like all metal screws and everything. And we use like high strength axles. So our center of gravity is like really, really low on a robot. We haven't had any issues with like tipping and stuff like you might see on other robots. You also have these like triangle braces, keeps everything nice. We have our inertial sensor on this plastic screw and on these rubber links. So yeah, it's like isolated from all the vibrations. We got an old inertial sensor here and haven't had any issues with it at comp. We also run like no odon pods, and our autos like hit most of the time. They're like pretty good. Although the auto skills, yeah, it got messed up by having no odon probably. So I probably want to run some odon later. My next year robot. I also have the air tank down here for better center of gravity. This aligner like fits underneath the robot or underneath blocks if they're already in the goal, so we don't have to worry about getting stuck if there's a block already like on the post of the goal. So that's at the correct height for that, and then the blockers sit like right here. That's why our brain and tank aren't further out. And we got it reinforced with this plate because we're at all 12 sheets of poly, so we wanted to reinforce it instead of double stacking it. It's pretty sturdy. It's never gotten stuck in the floor as far as I know. We got pretty good wire management for our like drive motors and stuff. Like here we got this nice cable, but then as I built more and more of the robot, I just got super lazy and just stopped wire managing properly. So yeah, it got messy over time because of that. We got this nice auto selector. I'll like turn on the brain and talk about it after it's done like loading. We also got this like cursed ass like middle goal liner. It like kind of worked because we ran out of plastic, so I wanted to make it metal. So yeah, it's just like standoffs that are bent a lot, and then we got mesh so that the blocks can still like come through this part of the intake really smoothly, because there's used to be a gap there. And this thing also helps because the brain's like literally about to touch the middle goal. It's like barely not touching, it's like below the middle goal height, so this liner prevents the middle goal from hitting it at all. Yeah, we also got like all our wires there, I guess. Pretty interesting. We also got like all these distance sensors here. We literally only use them at one point in skills. They're pointed at the right height for the GPS rep. We literally only use it after we cross the park zone in skills. I was gonna add like full Monte Carlo localization, but I got lazy. I didn't feel like doing it. Yeah, our intake like motors are pretty standard. You got 11 watt on the bottom here. You got a half motor on these stages, these two stages here, and then we got another half motor at the top. Although like the way that we gear them might be a little bit different, so yeah, I guess this one's pretty standard. Yeah, we got the 1200. I already talked about the way it's chained. So yeah, 1200, 1200, 600, and then right here for the next stage, it's on this half motor right here, and then we have like inside of there we have like half cuts and like bearings so that it's not cantilever. This sprocket right here, and it connects to this one, so it's 600 RPM on both this sprocket and the one above it. It's a pretty large sprocket for an S-Bot. I haven't seen many run it. Yeah, we have this like standoff coming across the intake as well for extra support, I guess. And yeah, this is like pretty fast, this intake. We also got this color sort there, optical sensor there. I'll run my code real quick so we can show other stuff. But yeah, we got radio. We did have a few issues with this. We actually really wanted to run like rubber links and like double radio, but like, I don't know, these things used to be where, our radio used to be here, these things, we added them, and it was really close to comp, so we just like stuck it here. I think we did DC like one time for a second in auto, which messed up our solo AWP, which is kind of annoying. Yeah, our wing aligner, or I guess we'll talk about our the rest of our intake first. So we got the hood here, it's like an active hood. I have like no air, but the piston only pulls it down, it doesn't push it up. And then like when you release the air, there's like latex tubing here, it'll like pull itself up. And like, I know a lot of teams had issues with like their hood, like having the right amount of compression where the block would like actually be able to touch this roller. And then like also not descoring the last block that they score. So the way that we did that was like, we have the piston pulling it down right now with zip ties. Like I have double zip tied just to be redundant. And then if I release it, it'll come up with the latex tubing. And then since those zip ties offer a little bit of slack with the piston, and we have the piston, there's actually no air in it now because it's single acting, then the latex tubing kind of has it allowed to move a bit, which gives it that compression and it prevents it from destoring the blocks. We got some rage bait happening here. Only thing I wouldn't recommend about this design is that it's like really close to 18, like this standoff here, so we had to like be really jank and remove material from this L channel here. So I wouldn't recommend doing that much at all. And this whole like top structure can kind of move because I don't have a brace across here. It's only like this hood. Yeah, so I guess that's about it for the intake. I guess this stage we got interesting gearing happening. So we got like, I think it's like a 3-to-2 ratio here with these sprockets because we couldn't fit a very big one at the bottom, and you want our motors at the bottom for better center of gravity. So yeah, we have 3-to-1 here, which gives us a total of 900 RPM. And this is like actually the tank tread sprockets that we cut to be like the same size as a regular sprocket, which happen to be the best diameter for us. Helps us get 7 in the mid goal really consistently, and also a pretty good long goal scoring, I guess. So now I'll talk about like probably the most unique part of our design is this triple state wings. So you can see it's completely folded in the robot, and we have the pistons like zip tied together, and then we pull like it up, and you can see the red piston is like a long piston, so it'll go from folded in the robot up to this position, I guess, which is where we want to score on the goal. I guess I press the button for that on the controller, but we have like 0 air, so it's not going to do anything. Oh wait, it was already up. That's how little air we have. Okay. I think. Yeah, okay. We have very little air, so yeah. Yeah, so it goes here, and it can go up with a small piston. We've got an old solenoid here to save weight, and like we have as short tubing as possible. I hate how it's kinked because you can't have 90-degree fittings on the old solenoids, but yeah, as short as possible tubing to save air. And then we also have one new solenoid with 2 separate wires on it that allow us to use the single acting hood piston and the single acting long piston on the bottom of the wing on the same thing. Yeah, there's air leak from this kinked tube. That's pretty jank. Yeah, then we can save weight by using only one solenoid, and we have like really short tubing for all of them. I use the same concept for the match load and the intake raised piston, just one U solenoid with 2 separate wires so they can be controlled independently, and the really short tubing to save air. We only use one long piston here, the rest are medium or small. All of them are small actually, except this one's medium, I believe. Then we can save even more air because we got 1 air tank and like 5 pistons that we use quite frequently. Yeah, our wing aligner is kind of interesting, I guess, because the triple state wing doesn't allow us to have it directly below the wing, which made it a lot worse. So we do have it angled in kind of like this to make it slightly better, but it was pretty bad. It kept messing me up. We do have it like kind of braced properly with these like bent standoffs because there's like no mounting points directly to it at the front of the robot. So we just have these bent standoffs to mount it on. This license plate isn't even an extension of the wing aligner. It's too flimsy to be one. It's just because we had nowhere else to put it on this side of the robot that would be like necessarily sturdy. We got this battery mount. We've never had issues with it falling out. It's like definitely not like stable, but it'll never fall out pretty much, and it never rubs on anything, so I didn't really have any issues with it. Never white screened or anything like that. Oh yeah, here's our auto selector. So as you can see, we have red and like double mid goal auto. So yeah, we can like press this thing to go to red, blue, or neutral. Neutral is for tests and skills. So we got skills 70, and we got skills, where is it? Where's my skills 97 at? there, skill 97, and then yeah, we have like right rush. We have quite a few autos here that we can use on the green screen there with using this potentiometer and this limit switch, I guess. And the nice thing about the potentiometer is it'll save what auto you're on even if you rerun the program, because like it's unlike a rotation sensor, it doesn't reset, it has this fixed amount of rotation it can do. So that was really nice for testing like autos many times in a row, which I really had to do for the skills auto. Yeah, we got this remote fill valve, I guess, makes it easier to fill air. We got, oh yeah, I guess I'll talk about the controls. So yeah, we got a bunch of scuffs on here so that we can like keep our fingers on the joystick, or my fingers on the joysticks. So yeah, this one's for the match load piston, and then this one's for the wing, and then I got like the small piston for the wing, like the scuffs for the big piston, and then outtaking, intaking, the hood. Hold both of these for the mid goal, and then we got like both of the macros for skills for these two. I just removed them for elims to make sure I wouldn't accidentally press them, but yeah, that's the mid goal macros for skills. Make sure we get 7 onto those. We also got like all these analytics on the controller, I guess. So the color is 1, so that's just red, and then we got the coordinates for the odom, so that's good for writing like any autos, so you can just slowly drive your robot along, record the coordinates and code it as you go, and also the angle for that same reason. You got the left and the right drive temperatures, so both 35, intake 1, intake 2, intake 3 temperatures. This is supposed to be the time since you ran the program, but like when you have so much stuff on your controller, I guess it bugged out and also put the angle, because yeah, it always just does that. The second line's always bugged out. And we got the battery level of the robot. Kind of forgot to mention a few other things, sorry for the background noise, but on the front drive funnel, we actually don't use the regular kind of layout that most people use, where you have like it's slightly forward, like you have the 2 long holes here and then 1 there. But in the front, what we have is just a regular straight sheet, and then we drilled like a hole between the 2 holes here, because like in the front we wanted to make sure it was completely side to side, which is like it really helps us aligning with the local as well, not only for funneling blocks. And then on our back high strength axle here, we've had a lot of issues like before with it bending. So we changed to using these M3 screws that have, of course, like smaller holes drilled into here. And then that keeps more of the steel high strength axle like intact here, which like, and you only need to have 2 screws. Like this thing doesn't move even though there's only 2 rather than 3 screws. And yeah, this hasn't bent since we like put this new high strength axle on, and like after our competitions in December, whereas like the old design with full size screws would bend in a few weeks of ramming into the goal. So yeah, this is definitely way better if you have any issues with your high strength axle ever bending. Also forgot to mention that we do like square our robot, so that means using shoulder screws whenever possible. So yeah, all the colored heads would be shoulder screws on our robot. So yeah, we don't really use that many shoulder screws, but what we do is like when we're assembling anything, like for example our drive, we don't put our wheels on yet. We put our metal together first. Same thing with like our intake, and then we'll have like a 5-wive C channel with shoulder screws on it, tightened to the structure temporarily while we tighten all the other braces, so that when we put everything together, it's perfectly square. I believe like Ryan Lau has some good videos of that, of squaring on YouTube, which are like, yeah, pretty much show the importance of how that reduces friction on your robot, and how like you can keep everything straight when you're building it, when you square everything. And yeah, I think that's about it. Oh yeah, we also box like everything. Like these screws go all the way from the bottom of the C channel to the top one whenever possible, which like keeps everything from like twisting at all. Like the robot doesn't really twist. Yeah, I think okay, now I covered everything. Much more to unpack here. It's a pretty standard S-bot. I say Chroma from 332A was like a huge help for everything on the robot and the code. He's actually the best. He's helped me with everything Vex for a long time. Herb Durable, I don't know what he likes to be called, from 36830A. I took a lot of heavy inspiration from his robot and his intake structure. He's also been a huge help. Yeah, I guess that's it about our robot. See you next year.